So, welcome back to the next lecture on thermal management systems in EV. So, last class we have been going on overview of what are the different thermal management systems and why is it required, and what are the different systems that get affected in a electric vehicle because of this thermal issues, and what are the systems that require this thermal management system is what we have actually has an overview of that. Now, just we will wind up with what we have done in the last session, just brush up it. So, the systems that require thermal management are battery thermal management for the battery, power electronics cooling for the power electronic converters and inverters that are present, and the next one is the electric motor, whatever the motor is, as we have seen what we have seen what are the different types of motors. So, we need to have cooling for the motor and the cabin climate control. So, in the last class we tried to classify the battery thermal management systems into two types. The first one is the active cooling system and the other one is the passive cooling system. So, again in the active cooling system we further classified into air cooling, liquid cooling and phase change materials, and the passive cooling systems there are two different methods. One is the thermal insulation and the heat sinks. So, these are the different kinds of the cooling systems that are present in the battery. We have seen the importance. Now, we will see what are the different types and how actually we can implement these cooling systems into the battery in an electric vehicle. So, even before that, let us understand what is the effect of temperature on battery life. So, always the battery temperature when under operation is limited or is having an optimal range of temperature to be operated, that is around 15 to 35 degrees centigrade. So, always we should ensure that the battery is operated in the range of 15 to 35 degrees centigrade, and we need to detect the critical point of the battery failures and deliver the alarm measures such that we always have a proper optimal thermal range in the battery. It is around 15 to 35 degrees centigrade, and next we need to suppress this thermal runaway propagation, and that is possible by continuously monitoring the system. Now, this is the effect of thermal management, and this is the effect of temperature on the battery life, and as we can see the total temperature line if you design. So, 15 to 35 degrees centigrade is the exact operating range which we should ensure for proper and safe operation of the battery. Even before that we call it as cold cracking, where we should not operate the battery below 15 degrees centigrade, and above 35 degrees centigrade again in case if operated the battery life gets degraded. Along with that also we should ensure the power limits of the battery along with the charge and discharge characteristics, and always it is desired, as said, the operating temperature should be around 15 to 35 degrees centigrade at rated power. So, in case if we have a battery which is discharging at a faster rate, say it is giving say some 100 amperes, even then we should ensure that the operating range of the battery is around 15 to 35 degrees centigrade. So, the same is illustrated in the form of a small figure, where you can see the charge and discharge should always happen in case of with the 15 to 35 degrees centigrade temperature range. So, the first type of cooling what we have is air cooling. So, in air cooling what we do is air is generally passed through the battery so that it cools down the temperature of the battery. So, since air is easily available for cooling purposes and it is widely used in many industries, however, it is not an effective coolant because it has lower heat capacity and low thermal conductivity. Most of the two wheelers are going with this air cooling because of the only reason, that is there is no maintenance cost for air cooling. However, the coolant effectiveness on the air cooling is not too high, and as I said, the advantage is there is no maintenance cost. And here in the two wheelers the battery is placed at the bottom of the seat, and during the discharging air flows increase with an increase in the speed of the bike or scooter. So, due to low maintenance cost there are very less systems that are using air cooling. So, mostly it is used in Toyota Prius and Nissan Leaf vehicles. and the cooling is possible either by forced convection, which is called active cooling, or natural convection, which is called passive cooling mode. So, in the natural convection, the cooling is suitable only for very low density batteries, and typically blowers and fans can be used to enhance the convection transfer rate. When air is used for cooling of the battery modules which are arranged in either series or parallel, the middle and rear portions of the batteries are at high temperature because of low heat capacity of air. So, when you have a battery pack, in a battery pack, the battery pack containing a series of batteries, the middle and back portion of the batteries will be having higher temperature compared to the front portion, because when air hits, it initially hits the front part and flows only through the middle and rear parts. So, the temperature of the battery pack near outlet is very high and the temperature distribution is highly non-uniform in case of air cooling, and to cool effectively we need to increase the flow rate and turbulence of air flow. So, the figure shown is what is the air cooling of a battery. So, as you can see, the air is getting circulated in between the battery pack, like you can see that arrows which are which indicates the air circulation. So, what exactly is happening here? We have a suction fan. The suction fan sucks the air into the system, and the air which is coming in the circulation form will be sent out through the air outlet. So, the battery units, the air will be flowing through the battery units, it gets sucked and it is passed through the outlet. So, there are various vehicles which are having popular battery packs, which are dealing with this air cooling battery packs, or the battery packs are being cooled with air cooling method. There are some of the famous are Honda Insight and Honda FI-EV, Hyundai Ioniq, Nissan Leaf, Renault Zoe, Toyota Prius. These are some EVs which are using this air cooling technique, and there are different methods of air cooling of the battery. The first one is the direct outside air will get will be hitting the battery and it will be sucked by the fan and it gets exhausted. In the second one, the outside air is directly flowing into the vehicle air or vehicle heater and evaporator core, from where the cabin air is being given to the battery pack, and this air which is given to the or which is being flown through the battery pack is sucked through a fan and it is giving or it is exhausted back. And the third one is the active cooling method. So, in the active cooling method, the outside air is first the outside air whichever is coming, it is first flown through the auxiliary or vehicle heater or the temperature core, and then it is given to the battery pack, and from there it is given to the exhaust fan and which is being exhausted back. Now, the difference between the both is, in the direct air cooling method, the outside air is directly given. So, there is no mixture of some other cabin air or some other temperature core which is not being considered, whereas in the active cooling it is being considered. And the next one is the liquid cooling. So, in the liquid cooling, the coolants have a high convective heat removal rate due to higher density and heat capacity when compared to air, and a liquid system is more compact than an air system. Why? It is because it saves up to 40% of separate power compared to the fans required for air cooling. Moreover, liquid cooling can reduce the noise level. So, you might have observed when you have an exhaust fan, it makes some sound, whereas when the exhaust fan is on, it sucks the air and it makes some noise, whereas while rotating, whereas in liquid cooling, that noise is not there. So, it is a smooth or without any noise it operates. However, the complexity of liquid cooling system is because of the leakage potential, that is, there is a chance of this liquid getting leaked, and this liquid cooling system is divided into two types. The one is direct cooling and the other is indirect cooling. So, first we will look into what indirect cooling is. So, in indirect cooling, water has been a very effective coolant for several industrial applications. However, since we know the water is a conducting material or it is a conductor, the main challenge is short circuited potential for direct cooling of batteries. So, what should be done? So, in order to avoid this short circuit issue, indirect methods are effective to avoid electrical conduction with cells while maintaining high thermal diffusion. So, the addition of electrical resistance may resist thermal diffusion, but it also has some effect on cooling and it is not very significant. Some EV manufacturers such as General Motors and Tesla are using indirect cooling in their cars. General Motor use cold plates between each prismatic cell, and the cold plates have several micro channels for convective heat removal from batteries. Tesla also has used similar kind, which we call it as wavy tubes, which are placed between the cylindrical cells. Thermally conductive and electrically insulated material is used to fill the gaps between the battery cells and cooling ducts. The wavy tubes may not be effective for cooling because of the small heat transfer contact area. It is safer from the mechanical electrical point of view. All the connections of coolants are kept outside of the enclosure to avoid leakage of coolant. The indirect cooling systems for electric vehicles and the conventional ICE cooling systems are almost same. Both circulate the coolant through a series of metal pipes, and these coolant, when circulated through the series of metal pipes, will transfer the heat away from the battery pack or engine. So, therefore, the coolant requirements for indirect cooling system will be very similar to traditional ICE coolants. The structure of cooling system that achieves maximum temperature uniformity is dependent on the shape of the battery pack and will look different for each car manufacturer. So, whatever the car manufacturer is, how the battery has been placed and what is the shape of the battery, how the battery pack looks will be different from each car to each car or each manufacturer to each manufacturer, and based on this shape of the battery pack, the cooling system also will differ. So, the uniformity also, the temperature uniformity will also differ. Based on the temperature uniformity, you also need to have a different cooling system for each or different type of cooling for each of the vehicle or each of the type of this battery pack in order to have a uniform distribution of temperature. And 99% of the coolant is made up of a commodity such as glycol or polyglycol and water, but that 1% additive package is what separates good from great engine protection and performance. When circulating a liquid coolant throughout metal piping, it is important to protect against corrosion to protect vehicle safety and performance. Metal is a very unstable, so it naturally wants to react with other elements by losing electrons to move to a more stable state. Corrosion happens because impurities in the coolant liquid have a positive charge on them, so they interact with the metal pipes and strip away from the surface. These additive packages, that 1% additive packages, they can be blended with antifreeze to form a coolant that protects against rust, scale and corrosion. The additive packages used in ICE vehicles contain corrosion inhibitors to protect the many types of metals that are found in cooling systems such as pipes, gaskets, connections, radiators, etc. Now, there should be some standard to give all this. So, the American Society for Testing and Materials maintains standards that coolant must meet for protection against corrosion of different types, different metal types. What is currently known about corrosion prevention is corrosion prevention in internal combustion engine cooling systems can be easily applied to the indirect cooling system in electric vehicle. Liquid cooling of batteries is shown below, and heat transfer takes from the cells to the cooling channels. The design strategy of thermal management system for battery modules, controller and electric motor are different in different kinds of vehicles. So, here we can see a liquid cooling of batteries, which is indirect cooling. So, here if we clearly observe the figure, the batteries which are the heat sources are placed and the liquid or the liquid coolant is passed through a channels in between the battery packs. So, there is a coolant which is flowing, and in between the battery cells or in between that you can see the channels which is carrying that liquid coolant. So, the liquid coolant which is being transferred from the coolant in to coolant out, this inlet to outlet is transferring the liquid coolant to uniformly distribute the heat and take away the heat from the cells, and it is being again collected at the end. And when you observe this again, we observe that the coolant is passed through a small metal type or metal pipes or some sort of tubes, and the standards for this as defined, it is through the American standards, which gives the additive which gives the coolant material or the property such that it also does not make these metal pipes more corrosive or corrosive. And here it is very clearly shown in the schematic what about the what or how is the liquid cooling system for batteries there. So, here in between the cells there is one coolant in and coolant outlet. So, through the coolant inlet the battery the coolant will be passed, the liquid coolant will be passed, and it is again collected back with when the liquid coolant is going into the system or into the battery cells, we can observe that the temperature is less. The second figure in the same will give you the information on the temperature distribution. So, as can be observed, the lower cells where the coolant is just going in has a very less temperature when compared to the higher one or the top series of cells. It is because the coolant has already got its is already in the process of absorbing the heat from each of the cell, and it is slowly passing through that. So, as the temperature keeps on decreasing inside the cell, the red spots what you see, which is having, which means it is having a higher temperature there, will slowly get reduced. So, this is the liquid cooling system generally used in a battery. The Chevrolet has its own cooling system in the indirect mode or indirect cooling, and which consists of a large number of micro channels embedded in the metal plates to carry out a coolant. So, that is what is shown in the figure. So, this plate is placed between two battery sets to remove the heat. So, that is what is shown here. So, this metal plate is placed in between the two battery sets, so that the complete heat will be absorbed and it will be removed. So, the next one is the direct cooling. So, in indirect cooling, one thing is very clear, that the battery is not having any direct contact with the liquid, only the liquid is flowing through some metal or the coolant is flowing through the metal pipe or through some channel, and it is absorbing the heat. Whereas, in direct liquid cooling, it is the direct immersion. So, the direct cooling systems place the battery cells in direct contact with the coolant liquid, and this direct cooling is also called immersion cooling, which covers the entire surface of the cell and cools it uniformly. So, as can be seen, the temperature distribution, all the cells do not have an uniform temperature or uniform temperature distribution. It is because of the coolant flowing from one part to the other part, it takes some time, it loses its some properties and so on. So, this is one of the major drawback or limitation of this indirect cooling. Whereas, in direct cooling, since the complete battery pack will be immersed in the liquid, the entire surface will be uniformly cooled, or it has a uniform temperature distribution across the cells. So, immersion cooling removes hot or cold spots in the cell and significantly improves the performance of the cell. The ideal coolant must be dielectric with minimum viscosity and high thermal conductivity and thermal capacity. So, the immersion cooling is widely used for data center servers and high power electronics devices. The BTMS for this method is not suitable for most mass produced EV due to high cost and safety concerns. So, this is not a suitable option for electric vehicles because of high cost and safety concerns. And the immersion cooling is useful for batteries of high performance EVs and EV racing. The fluid has a boiling point between 60 to 80 degrees centigrade, which prevent overheating of the cells and avoid thermal runaway. Modular type containers are used for the cells where they can be submerged in the liquid. So, in case of the indirect liquid, what we have seen is the coolant is being passed through the cells, whereas in direct cooling the complete battery will be immersed in the liquid. So, when the complete battery is immersed in the liquid, there should be various other alternatives or various other concerns that are to be taken care of. So, the first one is the coolant whatever we are using, it should have a very high thermal conductivity and thermal capacity, and the viscosity should be very minimal, and this is the figure shows you what immersion cooling is or how this immersion cooling is there. So, here the immersion cooling, the cells are placed in such kind of arrangement where the cells are placed in the liquid which is having, or the coolant which is having these properties. And most of the electric vehicles, in case if it is mass produced, as said, not preferable, but if you wanted high priority to the thermal management in this kind of direct cooling, we can go with this kind of cooling, and the where the liquid cooling is generally preferred in some electric vehicles like Audi R8, Ford Focus, Chevrolet Bolt, Chevrolet Volt, Tesla Model X, S and 3, Toyota, Volvo, and so many. So, these are few electric vehicles which are using liquid cooling in the battery packs. The next one is phase change material cooling. So, in this phase change material cooling, so the first one is the air cooling, where you have circulated the air through the battery packs. The second one is the liquid cooling, one way or the other we have circulated the liquid into the battery pack or the battery cells to make the temperature cool down. The next one is the phase change material, where we use a certain kind of material which absorbs heat significantly due to high latent during battery discharge. And these phase change materials have been used for thermal management, having a melting point in the optimum performing range of lithium cells. The cell temperature needs to remain for a very long time. Now, what are the kind of materials which you can use? So, paraffin is one such material. So, the phase change material as paraffin, it is having a melting point in the range of 32 to 38 degrees centigrade, which is mixed with graphite flakes to improve the thermal conductivity. And these graphite flakes will also create a semi matrix block which will contain the paraffin particles. When the paraffin melts, it stays with this matrix and the whole composition remains as the solid form. So, this when it is maintained in this solid form, the heat absorption will be more and it continues to absorb within that 32 to 38 degrees centigrade, or it tries to maintain the temperature within that 32 to 38 degrees centigrade. Now, the graph shows the time versus temperature for PCM or the phase change materials. So, with the time and with the temperature, with slowly increasing the temperature and with the time, the phase change material will have reach its melting point, and when it reaches its melting point, for a longer time the temperature is almost maintained at that value, which tells that the battery pack will be maintained or will be having a certain temperature within that limit. Now, there are various phase change materials which are used for battery cooling, and some of these materials are organic phase change materials, inorganic phase change materials, eutectic phase change materials. So, eutectic is hybrid of these two. So, some of the organic phase change materials are paraffins and non-paraffins, and the inorganic phase change materials are salt hydrates and metallic alloys, and eutectic phase change materials are combinations of organic and inorganic, or organic organic, or inorganic and inorganic phase change materials. So, most of the phase change materials used are paraffins, and the phase change material which we have selected, it should properly maintain the temperature of the cell around 25 to 35 degrees centigrade, and multi-phase modeling needs to be considered for phase change materials during the cooling of the batteries. Next, we also have another type of arrangement to effectively cool and maintain the temperature of the battery within the certain limit, that is called heat pipe. So, the heat pipes, they have been considered versatile in many industrial applications for their efficient cooling and thermal management. Similar to passive cooling method of phase change materials, applying the heat pipes to cool or remove heat energy from battery provides efficient heat transfer, low power consumption. In this mechanism, heat is transferred through latent heat of vaporization from the evaporator and to the condense. The working fluid can be passively transported back to the evaporator by capillary pressures. It is developed within the porous wick lining. Operating in this situation, the heat is continuously absorbed and released. So, the figure shows the flat heat pipe cooling of a hybrid electric vehicle lithium ion battery pack. So, as you can see, the cells there are placed within the heat pipe, or you can otherwise call it as a heat sink, where the heat sink is attached to the heat pipe, and from there the battery packs or the battery cells have been arranged. So, the heat pipe absorbs this heat in all the cells, and it is attached to the heat sink, which directly makes the heat flow outside the battery pack. So, that is what is shown in the figure here. Now, if we compare the cooling methods, so we have seen different types of cooling methods. Now, if we compare the cooling methods, the air cooling, the refrigerant cooling, and the coolant cooling. So, based on a small comparison, each one have their own advantages and disadvantages. Like advantages of air cooling are, it is very cheap, the effectiveness is not very much, which is the disadvantage. However, it is suitable for all cell types, whereas if you use some liquid cooling, then that case it is very effective. However, the indirect cooling method, it tells us that the uniform distribution of temperature is not proper, whereas in the direct cooling the uniform temperature is very good and it is more effective compared to air cooling. However, the disadvantage is it is a bit costly. Similarly, the other one, which is using these heat pipes or the phase change materials, are equally good with when compared to the other two and more effective. However, we need to go with extra arrangement of heat pipe and heat sink in case of heat pipes, or you need to go with an extra material which is called the phase change material along the battery pack, which will increase your cost. In case if we use this heat sink or heat pipe arrangement, the space requirement is also a bit higher when compared to the liquid cooling and air cooling methods. So, the table tells the advantages and disadvantages, the major advantages and disadvantages of different methods of cooling for a battery thermal management system. The next one is how to select the parameters for optimum performance. So, in order to select that, there are many parameters that are to be considered. So, what are those parameters that are to be considered? The first one is the operating conditions of the battery. Now, coming to this operating conditions of the battery, what are the major operating conditions of the battery? So, the first one is the current rate and voltage. You might have studied in the previous lectures, the battery will discharge with a constant current rate or a constant voltage rate. Same way it will charge through the constant current rate or constant voltage rate. Now, when it is charging through the constant current rate or the constant voltage rate, we need to see the optimal charge rate, which is 1 C, 2 C, half C, 0.25 C, whatever it is. So, that is one of the major operating condition. Based on the current rate, your thermal capability will change. If the battery is charging or discharging with say 2 C, then you have a high temperature around the battery, whereas if it is charging with say some C by 4 or C by 3 or C by 2, in that case the temperature across the battery cell will be less when compared to 2 C. Similarly, the other one is the load on the battery. So, these two also are equally important when the optimum performance of the cooling system is considered. The next one is the environmental conditions. So, the environmental conditions equally plays a role in selecting the battery cooling system. So, we cannot select some kind of cooling systems for other for some environmental conditions. So, the environmental conditions also need to be taken care of while going through the selection of a battery cooling system. The next one is the cells. So, what is the chemistry of the battery cell, like lithium ion phosphate or nickel metal carbide, whatever it is. So, that also affects, and the geometry of the cells also affect, and what about the reactions in the reactions in the cells also affect the temperature, and the properties of the cell materials also equally affect the cooling system or affects the temperature, which should be taken care while designing or while selecting a proper cooling system for the battery. And how the packaging of the cells is done is also to be taken care. So, how the packaging of the cells are taken care, whether it is through a thermal interface or is it through a cooling medium, and also the mode of cooling should be considered when you select certain concept or certain method of cooling. So, whether it is forced convective or natural draft cooling, or whether it is having a thermal interface and it is being fitted to the battery packs, and all these things also should be taken care. Now, when we consider or when we talk about the operating conditions, as already told, the operating conditions which include the load profile, which include the current rate, which include the short circuit, which include the over voltages, all these things are also the major operating conditions that are to be considered. And the environmental conditions that are to be considered, which include the altitude, which include the ambient and coolant temperatures, should be considered, along with the contamination and all. Along with that, the safety also should be taken care. So, what is the existing ecology of the what is the existing ecology, what are the safety measures that have been taken care for each cell should be taken into account while we design the system for optimum performance. So, as said, the cells, the geometry of the cell, how you have placed it, whether you have placed it in a flat way, like in case if we go through a car battery, the car battery is placed beneath the seat where it is placed in horizontal way. In case if you go with a vehicle, two-wheeler battery, placement of the battery pack will be vertical. So, the geometry also matters, and even in the pack you may have a uniform rectangle shape or a square shape, or some battery packs will have some 2-3 cells above the complete system and so on. So, all these will be affecting the optimum performance of the cooling system. And the next is the thermal interface which you have placed in the pack, whether the coolant medium along with the modes of cooling, all these aspects should be considered. And finally, when you come to the system, whether it is thermal interface between the pack or whether it is optimum fitting of packs or how it has been done. Now, how do we do all these things? So, for system as per the system level is considered, for the considering the optimum performance, we can use some intelligent algorithms through some simulations, which will give us the optimal performance and optimum sizing and optimum fitting of the battery packs. And coming to the other aspects of battery thermal management system, the battery thermal management system, the major thing what we need to do or what we need to consider is continuous monitoring of the battery pack. It is very, very important, because when the temperature raises below certain limit, there is an every chance for the battery to catch fire. Maybe some 5 degrees above the limit is fine, but more than that it should not be. So, the continuous monitoring of the battery pack is the cell temperature and the battery pack temperature is very, very important. So, that is what is being progressed now, and that is what is being researched now, how to monitor cell temperatures, how to monitor the battery pack temperatures. The battery pack temperatures are being monitored and it is being implemented in the new EVs. However, cell to cell temperature and the cell balancing, it is also equally important, and these are yet to come and be implemented in the electric vehicles. So, I conclude this session with the thermal management of battery, thermal management system of the battery or battery packs in electric vehicles and hybrid electric vehicles. So, we have seen what are the different types of thermal management systems that are available for battery packs and how they are implemented, maybe how they are implemented, what are the other materials that are required to implement, what are the advantages of each of the material, what are the limitations of each of the material, and what are the major factors or major factors that to be considered for optimum performance of the battery pack. So, this is what we have covered in this lecture, and in the next lecture we will deal with the thermal management in power electronics and electric motors together.